Hello, I'm Robert Syrett, and this is Know Your Nodes, a video series where I explore the building blocks of Audulus 3, the node library. This video is on splines. What is a spline? It's this thing. The spline is one of the original nodes in Audulus. It was a tool that Taylor, the author of Audulus, used back when he worked at Pixar as an animator. There it was used to track motion over time, and it does much the same thing in Audulus. When you input a value between 0 and 1, it correlates to somewhere along the x-axis and returns a value of whatever this piecemeal polynomial function is. It'll definitely make more sense if I use it in context. Alright, so I have a ramp wave LFO, and when I connect it to the spline, and connect the spline to the display, the little pink circle shows where the function is tracking. And we can get a little audio feedback, running this through a quantizer into a simple pair of oscillators. So here we're using it as a melodic sequence. And by attenuating the amplitude of the ramp wave, I'm only scrubbing through a portion of the sequence, and by offsetting it, I can change the starting point. Now, what should be apparent is that you can also use this to make audio waveforms. If this LFO, we're going at audio rates, the shape of the LFO would then become the timbre, and you could draw in your own custom waveforms, making it a graphic VCO. A droscillator, if you will. Zoot. Like with most of our oscillators, we need to have an oscillator core. This is going to be our phaser. You just bring up some more shapes. But a phaser goes from 0 to 2 pi. So first we're going to make an expression. Divides the output by that amount. Next, we'll need to have conversion from hertz to 1 per an octave. Making that exponential curve. For the time being, I'll just put in a very low pitch, making this an LFO that we can see on the waveform display. Okay, now let's connect that to a display and see what we get. So one of the things you may have noticed about the spline in Audulus is that it's all linear. If we want to make a curve, we have to have a lot of points along the spline. The maximum number of points on your spline is limited by the invisible hitbox on those points, because when you hit those invisible hitboxes, even when your mouse is just kind of adjacent to them, it will delete the points. That's how you edit the spline, so it's a bit of a trade-off. But there is a way around it. Because Audulus has a very easy-to-read format in terms of like how it's programmed, the forum member with the username JJThrash, aka Jimmy, devised a way to import a huge number of points and to create a very smooth wavetable. With basically this design, where there's a ramp wave feeding a spline into a curve. Let me bring one of those up. Now there are literally thousands of wavetables in Audulus, which, by the way, I will make available in the forum post for this video, and you can download them and use them however you like. Each one of them looks kind of like this on the outside. On the inside, it's going to resemble this a little bit, but with one major difference. There are 8 wavetables in here, and these correspond to 8 octaves. And as you can see, they slowly become more smooth because it's filtering out harmonics that are above the Nyquist frequency. which is a wonderful term that sounds very mysterious, but all that means is that it sounds less crazy at high pitches. This is also sometimes referred to as an anti-aliasing filter. Let's hook that up to a display. Very nice. One of the fun things to do with wavetables is to put them in a big switch and then crossfade between them all. It's a distinctive sound to wavetable synthesis that you might find on modules like the Morphing Cloud Terrarium, or I suppose there's a wavetable synthesizer in Ableton 10 now. There are even wavetable guitar pedals like the Geiger counter from WMD. I'm going to start with a via, because when I have one connection going to many inputs, it's much nicer to have a single input as opposed to have to individually patch the volt per octave signal to all the different inputs. I'm more or less choosing these at random. I don't really know what they look like on the inside. As you may have guessed, I haven't had a chance to fully explore all the several thousand wavetables that are in this collection. But I'm assuming if you gave it a little bit more time and thought, you could probably construct something that has a very specific timbral flow for whatever your need is. Okay, so those are 8 wavetables. Now I'm going to run them through a crossfading switch. Crossfading switch, if I open this up, is basically a regular switch with a bunch of crossfades. And it uses the smooth step function to smoothly transition between each crossfade as you sweep across the value range of 0 to 7, the normal range of the switch's input. Width parameter says how quickly it crossfades in between the values. So with the width all the way turned up, it's continuously crossfading through all the different waveforms. If I leave it in the middle, crossfades a little bit, then it plateaus and it just sits on a static waveform for a while. And if I have it all the way turned down, it basically switches instantly between the different wave shapes. This will be a lot more clear when I attach modulation to the input and we can listen to the results. I'm just wiring it up, plain and simple. And I'm going to put a little level on the outside. That'll act like a VCA. And another level which will act as a volume knob. Alright, that's working. Now I'm going to bring up an ADSR. Connect that to the VCA. And I'm going to bring up a MIDI input. There's the pitch. There's the gate. Start a sequence. Okay, and now I'm going to scale the modulation. Go from 0 to 7. And let's put an LFO on it. This is the pure crossfades. And this is with some stair stepping. And this is all stair step. And that's more or less it. As you can see, there's a lot of possibilities with the spline node, and I've just really only scratched the surface. You could run these through each other as wave shapers as well. Or you could use a wavetable as its own sequence. There's lots of fun tricks that you can play. But I think that just about covers it for today. Please leave a like and a comment if you're so inclined. And be sure to visit the forum so you can download all of the wavetables in Audulus format. And for the computer savvy among us, I'll even post a link to the code that was used to generate these wavetables. Thank you very much.